Welcome to the Explainer. Look, as a pro, you already know your way around a compressor. But let's be honest, memorizing the complex proprietary code languages of Carrier and Bryant systems, it's a massive headache. Today, we're taking those blinking lights and turning them into plain English. Let's decode them.
You know the feeling. Staring at a blinking LED or some cryptic fault code can be incredibly frustrating, but I want you to change your perspective for a minute. Try framing it not as a nuisance, but as the machine actively trying to speak to you. It's giving you the exact clues you need to solve the puzzle. You just need to know how to translate them.
So, here's our game plan for today. First, we'll cover the universal first steps. Second, decoding ductless systems. Third, residential Infinity flash codes. Fourth, commercial comfort link diagnostics. And finally, we'll wrap up with some common cures and remedies.
All right, Section 1, the universal first steps. This is what you do before you tear the machine apart. Okay, first rule, don't jump the gun. According to the service manuals, if there's no error displayed immediately, you absolutely must wait up to 5 minutes. Now, I know 5 minutes feels like an eternity when you're roasting in a sweltering hot attic, but some of these errors are in a strict retry loop. Next, you want to recycle the power and give the system a minimum of 10 minutes to see if that error triggers again. And always check your basic power limits. Ensure your wire harnesses are fully seated and verify equipment sizing and refrigerant charge before digging any deeper.
Moving right along to Section 2. Decoding ductless systems and making sense of those E and F codes. So when you're elbow deep in a Bryant or a Carrier ductless unit, your eyes should be peeled for E and F codes. Those letters and numbers are basically your roadmap for where to put your multimeter. They might look intimidating at first glance, but they're actually a highly organized map pointing directly to the system's sensors. Take a look at this sensor map. For instance, if you get an E4 or E60, that points right to the T1 return sensor on the indoor unit. Seeing an F1 or E53, that means you've got an issue with the T4 outdoor ambient temperature sensor. So, what's your next move? You get in there and measure the sensor's resistance value. If it's properly wired but doesn't closely match the spec charts, boom, it's a dead giveaway. It's time to replace the PCB sensor.
Now, let's talk about the dreaded E1 communication error. We've all been there, right? The manual gives us two really clear checks for this headache. First, verify if your condensate pump safety switch has tripped and broken the connection. Basically, just make sure it isn't breaking the S wire. If that looks fine, you might be dealing with stray induced voltage on your communication wire. Disconnect the S wire from both ends, reapply power, and measure it to ground. You want to see 0 volts. If you're reading 20 volts or more, well, you've got a communication error that requires fixing or replacing those wires entirely.
All right, shifting gears to Section 3, residential Infinity flash codes. Let's translate those flashes. Now, instead of giving us nice digital screens, these residential systems often speak in 2-digit flash codes right on the outdoor control board. But if you group these flashes logically, they become so much easier to memorize and diagnose out in the field. The absolute crucial point here is distinguishing between the pressure faults. If you see code 31, that's a high-pressure switch trip. This means you need to recheck your refrigerant charge and really inspect your coils for severe airflow restrictions. On the flip side, code 32 is a low-pressure switch open. For this one, you still check your charge, but your focus shifts to verifying that your indoor airflow is sufficient. It's two similar-looking codes, but two completely distinct diagnostic paths.
The board is also going to tell you if the system is literally suffocating electrically. Encountering a 71 or 72, that means the system's internal compressor overload might be tripping, or maybe a start relay is failing to release. On the other hand, if it's flashing a 46 or 47, that points to serious line voltage issues. A brownout triggers that 46, meaning line voltage has dropped below 187 volts for at least 4 seconds, and it won't resume operation until it climbs back over 190. And if you get a 47, well, that just means there is simply no 230 volts at the contactor at all.
Let's leave residential behind for a minute. Section 4, commercial comfort link diagnostics, navigating those heavy-duty rooftop controls.
All right, stepping up to the heavy-duty commercial Comfort Link packaged rooftops. With these Comfort Link version 5.x systems, you transition away from counting blinking lights to actually reading detailed scrolling marquees and extensive service analysis tables. It's highly detailed, sure, but only if you follow the logic.
This service analysis table is an absolute lifesaver. Notice how something as surprisingly simple and, let's be honest, annoying as an employee leaving a door propped open can completely skew your suction pressure high because of the massive heat load. Meanwhile, if your suction is low, you might literally just need to clean some dirty filters. And if you ever spot a frosted liquid line, the table points directly to a restricted filter dryer that needs to be removed or replaced.
Now, if that scrolling marquee specifically tells you indoor fan contactor open, the service manual gives you a rapid-fire checklist. You want to run through this in exact order. First, check if the power is just completely off. Simple, right? Second, look for blown fuses in the field power circuit. Third, verify your control power by checking those secondary fuses. And finally, check the transformer to make sure the primary windings are actually receiving power.
Now, what if the gas heat fails? You rely on the active alarms on that scrolling marquee, sure, but don't overlook the physical remedies. If burners won't ignite, it could be water in the gas line requiring you to drain it and install a drip leg. Or there might simply be air in the line. The manual actually says to purge the gas line of air and let it dissipate for at least 5 minutes before even attempting a relight. Simple physical checks like this save you from swapping out expensive parts needlessly. And as always, inadequate heating often just points straight back to restricted airflow.
Okay, bringing it all together with Section 5, Common Cures and Remedies. This is the Master Diagnostician's Playbook.
We've looked at 3 totally distinct machine languages today: ductless sensors, residential flash codes, and commercial marquees. But bringing it all together reveals that the fundamental practices really remain the same across the board. Always verify your proper 230-volt power and check your fuses before doing anything else. Get comfortable ohming out thermistors and sensors against their spec charts. Check all your wire harnesses for secure connections and test for that stray-induced voltage. And honestly, perhaps most importantly, verify your airflow and clean those coils before you ever assume you have a refrigerant leak. Sticking to these foundational steps will solve the vast majority of your headaches.
And look, as every single one of these master manuals explicitly reminds us, translating these codes is strictly a job for trained professionals. Servicing air conditioning equipment can be inherently hazardous because you're dealing with high system pressures and live electrical components. Always, always prioritize your safety out there.
So, I'll leave you with this final thought. These machines are practically screaming what is wrong with them through E-codes, flash counts, and marquees. The next time you're out on a call facing a blinking LED or a marquee warning, will you listen to what the system is actually saying, or will you just guess? Thanks for joining me on this explainer, and I'll see you on the next one.